Let's go through use Pythagoras' theorem to find the hypotenuse on Mangahigh, and we'll start with the teach me section first. Okay, to begin with, we've got 7 squared, which is 7 times 7, it's 49. The square root is 64. We have to find a number multiplied by itself is equal to 64, and that's 8. 8 times 8 is 64. Over here, 16 plus 9 is 25, so we need a number that multiplies by itself to equal 25. So it's 5 times 5 is 25, so it's the answer here. Alright, this is demonstrating Pythagoras' theorem. We have 8 squared, which is 64, and 6 squared, which is 36, is equal to 10 squared, which is 100. Alright, so we can see both the shorter sides added together is equal to the longer side, and that's always the case for a right angled triangle. Here we've got a squared, which is one of the short sides, and you add together plus b squared is equal to the long side, the hypotenuse squared. So what we have here, if we want to complete some of these things, we've got a squared in this case is 3 squared, which is 9. B squared is 4 squared, which is 16. Add those two squared numbers together and we have 25. Right, so to reverse this, the opposite of squared is square root. So we take the squared over the other side, it becomes square root of 25 is equal to 5. Okay, time to practice now. Alright, so we're into the actual game here. Evaluate the square root of 8 plus 8. Now 8 plus 8 is 16, and we know the square root of 16 is 4. Right, what we have here, which are the answers give a correct connection between the three sides. What we're going to have is a squared is equal to c squared plus 6 squared. In other words, you're putting a square on both of these shorter sides, and it's equal to the longest side squared, which is this one. Longest side squared is equal to adding the other two squares together. Right, so we have 20 plus 5 is 25, the square root of that is 5. Side FE is 6 centimeters. Side DE here is 3 centimeters. Alright, so what we need is to square both of those. We have 6 squared is 36, and 3 squared is 9. 36 plus 9 and, well, anyway, this is actually here is 6 squared, which is 36, plus 3 squared is 9. So that's what we actually want. We don't want to take the square root of it, because, see, we're looking for the hypotenuse squared. Okay, so we'll go for this one. The side AB is 4 centimeters. The side BC is 6 centimeters. Remember, this is a little bit out of, not to scale, because, you know, they're saying that this is 4 and that's 6, which doesn't seem to make sense, but that doesn't matter, it's not the point what we're doing here. What you have to do to work out the length, now we're not looking at the length squared this time as in the previous one, we're just looking at the length, so it means we're going to have to take the square root. To find a length, we have to take the square root. Okay, so we have to take the square root of the other two sides squared. So we've got 4 squared, which is 16, and 6 squared, which is 36, and we're taking the square root of that, so it's this one here. The side DE is 3 centimeters, and EF is 4 centimeters. We're trying to work out the length of a hypotenuse, so we must take the square root to find the length. So we take the square root of the other two sides squared, which are 3 and 4 respectively. So it's this one here, 3 and 4, and you're squaring them. Alright. The length of the hypotenuse of a right angled triangle is the square root of 15. Alright. So it really is the length of the hypotenuse is going to be the square root of the other two sides added together after they've been squared. So if we look at the other two sides, and let's see, could one side be the square root of 6 and the other side be 3? Well, let's try squaring both of these and adding them together. So if we square that one, we get 6, because you're taking a square root and then squaring it. They cancel out, so we end up with 6. If we square the 3, we get 9, so 6 plus 9 is 15, the square root of 15. What we've got here, that is, it says here which of the pairs of numbers could not form, so that one's a good one, that one's going to works out to be the 15 that we want there. This one here, if we square this, we get 14, square this we get 1, so we've got 15, that's okay as well. Square 2, we get 4, square this, 9, so 4 plus 9 is 13. Well, that's different from the 15, so we're looking for one that does not form the lengths. So in order to form the lengths of the other two sides, it would have to be 15 when you add the squares together, so that one does not. The length of the hypotenuse, the same thing, we're looking for what does not or could not form the hypotenuse. So what we've got here, 2 squared is 4 plus square root of 14 squared is 14. So 4 plus 14 is 18. So it's going to work properly. The two sides could be 2 and the square root of 14. Over here we have square root of 2 squared is 2. And 4 squared is 16. 2 and 16 are 18, so that one's okay. 1 squared and the square root of 16. We square that, we'll get 16 plus 1 is 17, and it's not. So you can't have those two sides as being sides that will then match the hypotenuse of square root of 18. No, it's not going to work, so we'll click on that one. Okay, we're doing the same thing here. Right, so we've got another one here. Square root of 32 squared is 32. And then 3 squared is 9. So it's going to give us 41 altogether. That's okay. Square root of 5 squared is just 5 plus 6 squared, which is 36. So 36 plus 5 is 41. That's okay. 5 squared is 25 plus the square of this will cancel it out. So 14 plus 25. 14 plus 25 is going to be 39, so it's not going to work, so we'll click on that one. Alright, perpendicular height is something slightly different. We're on fire here, as we can see. This is quite awkward. Okay, so we're given an area. Let's bring up Notepad to help us out here a little bit. Okay, so what we've been given here is area of 36 meters squared and a height of 6 meters. Alright, so we know that the base, let's say base base times height of 6 is going to be, divided by 2, we'll use a slash as divided by 2, is going to be equal to 36. Alright, so because base times height divided by 2, which is the same as a half, is the area of a triangle. The area of a triangle is given as 36. So what we can do is we can actually take this divided by 2 onto the other side. It becomes times 2. So we will have b times 6 is equal to, and we can take the other one, take the 2 onto the other side, times 2 gives us 72 on there. Okay. Now also b, now take the 6 onto the other side, divide on the other side. You've got to do the opposite operation on the other side. So we've got 72 divided by 6. Alright, so think of a way of dividing by, I think it's 12. Okay, so 12, we've got that there. Alright, so b equals 12. And so we know that the base AB is 12. So we know that AB is 12. Okay, now if we go, actually we can create a right angled triangle here. Right angled triangle. Just visualize it here. Now we know that the height is 6 because we've been given that there, and the length of the other short side of a right angled triangle is going to be also 6 because AB is 12. That means from here to here, from the middle to B, is going to be 6. It's going to be our other side of the right angled triangle like this here. So we have 6 and we have 6 up here as well. Okay, so what we've got to do is find the length of side AC, and that's a hypotenuse, so it's the same as this one here, same as that, because isosceles triangle, they're both the same, so we can work out any one of these here. So we've got to work out this side here, and it'll give us the answer. So if we take 6 squared is 36, and then 6 squared is 36, will be 72. Okay, so in order to use Pythagoras, we've got to take the squares of those two short sides, 72, and then we've got to take the square root of that to give us our answer at the hypotenuse. So it's indeed this one over here, square root of 72. There we go, and we've got a bronze, and I can carry on with the rest of that later on, but I think we'll leave it as it is for now.